So the function is given by f of x equals 5 plus 3x plus c x squared minus 2x cubed. And we are told that there's a point on this graph at x equals 2 where the gradient is minus 5. And we are asked to find the value of c. Right, c just being that constant in our function. So first of all, looking at the function, what type of function is it? Highest power of x is x to the power of 3, so it's a cubic. The coefficient of x cubed is negative, so it is a negative cubic. Alright, and we're told when x equals 2, the gradient is negative 5. So it could be at this point here that has a negative gradient, or this point over here. We're not too sure, but we know it's at x equals 2. Find the value of c. So how do we use this information that we're given? We're given information about the gradient. So to use that, we need to first find the gradient function, f prime of x. So to get the gradient function, we take the derivative. So the derivative of a constant is 0. So the derivative of 5 is 0. You can think of that as on a graph, if we plot the line y equals 5, what is the gradient of a flat line? Right, it has a gradient of 0. Next up, plus 3x. The derivative of plus 3x is plus 3. Again, if you think of the line y equals 3x, what is the gradient? Rise over run is 3. Although shortcut to remember that is the derivative of a constant times x is just the constant. Right, it is the gradient. The derivative of cx squared, we take the power 2, multiply it out the front to give 2 times c, and then we subtract 1 from the power. So 2 minus 1 gives 1, which we don't need to write. And finally, minus 2x cubed, the power of 3 multiplied out the front gives minus 6. We then subtract 1 from the power, leaving us with minus 6x squared. And we don't need to write the 0 out the front, right, just to tidy it up. So that is our gradient function. So for any input x, the output is the gradient of our function at that x value. So now looking at the information we were given again, we were given an x value and the gradient at that x value. So we can substitute in what we know and solve for c. So in for the gradient, we'll go negative 5. Then our gradient function is 3 plus 2 times c. That's what we're looking for, so that stays as a variable. X, it's when x equals 2, minus 6 times 2 squared. So again, all we've done here is we found the gradient function by taking the derivative, and then we've substituted in x equals 2, and the gradient equals minus 5. So solving for c, so 2 times 2 gives 4. 2 squared is 4 times 6 is 24, so minus 24. I'll add, so 3 minus 24, what's that, minus 21. Add 21 to both sides, we get 4c equals 16. Dividing both sides by 4, c equals 4. Alright, just rereading the question, find the value of c. Okay, so we found the value of c, and we're done. So to quickly recap that, we started off by being given a function, however there was this unknown constant. We were given some information about the gradient at a point, so to use that information, we had to find the derivative, and we had to set it equal to negative 5. So if we did both of those things, that is the achieved component. We then also substituted in x equals 2 and solved for c. And if you got that far, that is the merit component.